Question number 5, June 2012. Question A asks you to find the length of the arc. Length of an arc is really easy formula. It is S equals R theta. R being the radius, theta being the angle. R is 18, the angle is 2 pi over 3. You times those together. 18 times 2 is 36. 36 divided by 3 is 12, so the answer is 12 pi. The question tells you that you had to have your answer in terms of a multiple of pi, which it is. Stick meters on the end because you have just found a length. Question B. Question B asks you to find the angle PTQ. Now if I show you the diagram here, here's the angle PTQ. You want to find this angle here, which is alpha. You should realise that this is a quadrilateral, and all quadrilaterals add up to 360 degrees. So if I just quickly draw that quadrilateral, which is a kite, that's 90 degrees and that's 90 degrees, and it tells you that that one is 2 pi by 3. Now you should know that that angle, that angle, that angle and that angle all add up to 360 degrees. You know that that's 90 degrees and you know that that's 90 degrees. You should also know that 90 degrees is pi over 2 and that one is also pi over 2. Now you know that 180 degrees is pi. So a quadrilateral should have 360 degrees, which is 2 pi. Now you know that that angle there and that angle there is pi over 2 and pi over 2. Well, a half a pi plus a half a pi is 1 full pi. So that angle there and that angle there must also add up to 1 full pi. You've already used up 2/3 of the full pi there, so you've got 1/3 of pi left for that angle there, which is alpha. So alpha must be 1/3 of pi, or written as pi over 3. Question C is a little bit tricky. First of all, you can't really see the shaded region, so if you read the question, it tells you that the shaded region is bounded by the arc PQ and the two tangents, so I've just shaded it in roughly on here, so we're looking for this area here. What we need to do is find the area of the whole quadrilateral and then take away the area of the sector. Now the area of a sector is the formula that you've learned this year, which is half r squared theta, and all you have to do is find the area of this kite. Now the way that my brain's looking at this, I want to half that into 2 right angle triangles. I know the area of a right angle triangle and then I can double it to get one side and 2 sides. Now, if you're looking at that as a right angle triangle, you need to find half the base times the vertical height. Not that line there, because that's the hypotenuse. You want to find this side here. So, if I draw that as the triangle on there, like so, that's the 90 degrees, that's 18, and that's the side that we need to find half. Area of a triangle is half base times height. So to use trigonometry, I'm going to have an angle there. That angle there is half of that angle here. So half of that angle there is 1/3 of pi. So I know that that's pi over 3. So I'm going to use trigonometry. I've got an angle. I need the opposite. I've got the adjacent. So what I'm going to have to use is tan or torr. So because I want to find the opposite, I put my finger over the opposite, which is like so. Tan of the angle times the adjacent. So the opposite equals, or x equals, tan of pi by 3 times by 18. Now back in year 10 or year 11, when you learned trigonometry, you didn't know what a pi was. You only knew what degrees were. So can you please put that in your calculator as a degree? You know that pi is 180. So you know that 180 divided by 3 is 60. So can you make sure that you use tan 60 on your calculator? So on your calculator you do tan 60, make sure you close your bracket because the calculator won't know what to do. So it's tan 60 times by 18, which is 18 root 3. So that side there is 18 root 3, this side. Now to find the area of that triangle, we're going to do half base times height, which is half times 18 root 3. Because we want 2 of these, we're going to have to double this answer. So you can either ignore the half and just do 18 times 18 root 3, or half it and then double it again. I'm just going to do 18 times 18 root 3, which is, in your calculator like so, and the answer is 561.1844. 561.184, and if we round it up, that'll be a 5. Now that is the area of the whole quadrilateral. We now want to find the area of the sector. So, area of a sector is half r squared theta. So it's half times the radius squared, which is 18 squared, times theta, which is the full angle included in the question, which is 2 pi by 3. So on my calculator we do 0.5 times 18 squared times by, and use your fraction button, 2 pi, start again, 0.5 times 18 squared times by 2 pi by 3, which is 108 pi. So to find the area of the shaded region, so shaded area equals 561.1845 minus 108 pi. And then stick that in your calculator. So that is 561.1845 minus the answer that was already on my calculator is 221.89. Tells you that you have to have your answer to 3 significant figures, so that 8 will round that one up. So the answer is 222 meters squared.